services kind of maybe up and running, but we don't really have any unit tests that try to test pathological cases where you probably get a warning or get an error or you know the exact output of what you want to do. So for example, if you have a statistical method and you know that the answer after running it with this data set should be 8.41, you may want to check for that. So let's try some of that. So what we're going to be using is called the TestThat package. So if we have use this loaded up, use TestThat, if we run that, what's going to happen? It's going to create TestThat to the suggests field, the description. So we see, again, TestThat is added. It creates two folders, or a folder in here, tests, and then a TestThat folder, and then a TestThat.r. So what we're going to do is create a test. Just testing printer functionality. So context gives you some ideas as to what is going on with this specific test, and then we run the function TestThat. So I'm going to load up TestThat. TestThat, and then you have a description and then code. So we are testing whether printer gives us the same output. And then the code, we are going to encapsulate that in curly braces because we're going to do a few things here. Because I'm going to be creating some random data, I'm going to set a seed. But where do we save this? So hold on, let's make the test first. So again, let's go to our printer function. And what we're going to do is go to our, so that is now an untitled, title one, I believe. So res should expect some printing out, right? So let's say expect that nrow res 5, or nrow res is equal to 5. So if we look at the help file here, so there's an old style of testing. I didn't actually know that. So we should check out some of the expect functions. Expect. So there's expect condition, expect equal, right? So for example, we might be able to say like nrow res, or we should be able to say expect equal that. So we get that to be true. If we had tried for example, you're going to get an error. So what happens is when we run this test, it is going to check that these conditions are actually met. So we don't put these things in the R folder. We put them in the TestThat folder. So I'm going to call this testprinter.r. Okay, so this does some random silly things. But let's say col means res. I'm going to say Dput. So Dput is a way to grab output and get the R code that would be used to generate it. So I'm going to say cm is col means res. And because I set the seed, this should be exactly the same every time. So I'm going to say expect equal cm, and then this vector right here, right? So if I do this, we should get that thing to be true. Now if I had reset the seed, if I change the seed, these column means are going to be different, and that test is going to fail. Or if something in the printer function, for example, change the seed or somehow change the output of res, then that'd be like a list or something like that. This is not going to come up true, and it's going to tell me that it's breaking some of the previous functionality. So unit tests are really good, and they're especially good in edge cases. So if you ever get an issue on GitHub, for example, that somebody used your package in a way that you didn't perceive would be used before, or how it would be used before, and they got an error, and you don't ever have to deal with that again, or that condition's always going to be fixed, you should create a unit test that will kind of capture that, just to make sure that if you did change the functionality, that problem is never going to be encountered again. So here, if we say build test package, it's going to run the TestThat.r. And again, you don't really ever have to run this, or you don't have to really edit this file for the most part. Okay, so just reading functionality, we got a tibble. CM is not equal to that. So I might have run this. I think I ran res a few times before I actually set the seed. Yeah, so these are actually wrong. So we got an error, right? So we got an error because the output of the column means was not exactly the same. So this is the errors you get. So it's a failed one. So again, after fixing it, let's test the package again. And again, that was because I didn't run res after I had set the seed. And now we have 2 passing ones and everything's great. So if we run check package, it'll run testing in the background during these checks. So we can again see everything going on back here. So it's checking, it's building, and it is going to run our vignettes, it's going to run our examples. And then one thing I will show you that we talked about in the last kind of lecture about code coverage, I'm going to show you 2 ways to calculate that coverage yourself using the cover.r package and see where some of the code is not being evaluated. So again, this package is not very fancy. There's not a lot going on. It's just 2 functions that really print out things. But if you have a lot of if statements, for example, which I will make a few, then some of your code might not really be tested, right? So if you say, I figured out all the ways someone can break this package, and I put an if statement in there for every single one of them, then I fixed it. But if you don't have tests that really fall into those cases in those if statements, then the code's not really being tested, right? So that is a reason to create some of these pathological cases or some of these strange data sets that may be encountered in the wild. So here it says it ran the tests and everything's going well. So the last thing I will show, in RStudio there should be an add-in, there's a coverage, calculate package test coverage. So if you click that, it should actually run the calculation to test coverage, and it tells you, for example, the printer has 100% coverage, right? And if you click that, it shows all the green where it was run, and hello, I didn't do any testing, so it's all red. Now note, by default, using this add-in, it's going to do just the unit tests. If you want to see package coverage, type equals all, which is the vignettes, the examples, and the tests, this is going to give you a little bit different of an output because this only looked at the unit tests. We don't have unit tests for hello. We do have unit tests for printer. But the hello functionality is run with the examples. So I'm saying look at the vignettes, examples, and the tests and give me an idea of package coverage. And again, in the Travis YAML file, that's what we're going to be putting online. So some may disagree with that. The defaults disagree with that kind of sentiment for calculating package coverage, but I still think it's okay. So now we have some quick unit tests. We should expand on these. Pretty much every function that you have that is definitely facing a user, every exported function should at least have some basic unit tests in here to make sure the output matches up with what we think. All right, that's just a very quick overview. There are a whole lot of things in testing that you can do, especially with associated data sets and embedded data sets, but we'll cover using data in a package a little bit later.